Good day everyone, I am Krisa Pahares from Group 16. So without further ado, let us start exploring the nano world. So what are the learning outcomes from this lesson? First, define nanotechnology. Second, discuss the contribution of person to this subject. And lastly, appreciate the uses of nanoscience and nanotechnology. I'm sure everyone is familiar with nanotechnology because you are using gadgets such as iPhone, LED TV, laptop. So those are examples of nanotechnology in a small scale. So in the past, you are using a monitor that has what? That has a big back. Because of nanotechnology, it became thinner, right? A good example this also is your cell phone. Dati ang mga cellphone makakapal, but today it became thinner, right? And later on, I will discussing it with you. So right now, we will talk about nano. From the Greek word nanos, which means dwarf or little old man, meaning extremely small.
Just how small is Nano?
The term nano refers to a unit meaning 1 billionth or 10 raised to negative 9. So it can compare to a size of a DNA. Now, for example, sa blood cell, may nucleus, may DNA. We all know that a cell, there is a nucleus which can controls everything. So, inside the cell, there is a DNA. So, ganun po kaliit yung nanotechnology in a small scale. So, the human being can manipulate the materials in a nanoscale level. So, super high-tech, right? Mas manipis yung cellphone, mas manipis yung TV, mas high-tech because of this nanotechnology. As you can see on the figure, mas maliit pa siya sa bacteria. But of course, mas malaki pa siya sa atom. Kung makikita mo, andun yung gap ng technology. You can manipulate a materials. It can be solid, liquid, or gas. You can manipulate matter in this scale. Of course, but today they can manipulate things like in technology now, particularly intangible objects in gadgets. Next, let's talk about nanoscience and nanotechnology. When we talk about nanoscience, it is the study. It's all about knowledge. Of course, you already studied what is science. It's all about a systematic model of knowledge based on observation and experimentation. So, lagyan mo lang ng nano yon. It is a systematic study in a small scale, a body of knowledge based on your observation and experimentation. So, it's all about knowledge in a small scale. That is nanoscience. While nanotechnology is the application of nanoscience leading to the use of nanomaterials and nano-sized components in useful products. Nanotechnology will eventually provide us with the ability to design custom-made materials and products with the new enhanced properties, new nanoelectronic components, new types of smart medicines, and even interfaces between electronics and biological systems. These newborn scientific disciplines are situated at the interface between physics, chemistry material, science microelectronics, biochemistry, and biotechnology. Control of this discipline. Therefore, requires an academic and multidisciplinary scientific education. Although nanotechnology is a fairly new science, the chief concepts have been developing over the course of 50 years. Interestingly, we have been employing nanotechnology for over 1,000 years, from painting to making steel. Although what has changed recently is our ability to manipulate and engineer in the nanometer scale. One of the most documented examples of nanotechnology known in history is medieval stained glass. Artisans were the first nanotechnologies as they unaware trap gold and the particles in the glass matrix in order to generate the rubber red color in the windows. Medieval stained glass windows are examples of how technology was used in the pre-modern era. Stained glass windows were used in churches, but were also found in wealthy domestic settings and public buildings such as town halls.
What is NanoWorld? NanoWorld is the global market leader for tips for scanning probe microscopy and atomic force microscopy. The atomic force microscope is the defining instrument for the whole field of nanoscience and nanotechnology. To understand the nanoworld, here are presented important personages who have contributed to the growth and the study of the nanoworld. Richard Feynman. The retroactive rediscovery of Feynman's plenty of room gave nanotechnology a package history that provided an early date of December 1959. Feynman's stature as a Nobel laureate and as an iconic figure in 20th century science surely helped advocates of nanotechnology and provided a valuable intellectual link to the past. Richard Feynman is famous for his work on quantum electrodynamics, which describes how light interacts with matter and how charged particles interact with each other. Eric Drexler. Eric Drexler is a visionary scientist and engineer, thought of as one of the founding fathers of nanotechnology. He is most known for being the driving force behind the concept of molecular nanotechnology. His paper on the nanosystems, molecular machinery, manufacturing, and computations received the Association of American Publishers Award for Best Computer Science Book of 1992. Drexler founded the Forsyth Institute in 1986 with the mission of preparing for nanotechnology. Nanotechnology and nanoscience got a boost in the early 1980s with two major developments: the birth of cluster science and the invention of the scanning tunneling microscope, or STM. These developments lead to the discovery of polymerase in 1985 and the structural assignment of carbon nanotubes a few years later. Bird, Weinig, and Heinrich Rohrer. Weinig and Rohrer developed the scanning tunneling microscope in 1981. The scanning tunneling microscope is an instrument for imaging surfaces at the atomic level. They were awarded the Nobel Prize in Physics in 1986. Weinig and Calvin Quitt and Christoph Gerber invented the first atomic force microscope in 1986. It can image almost any type of surface, including polymers, ceramics, glass, and biological samples. In 1989, the first commercially available atomic force microscope was introduced. IBM researcher Don Egler was the first to manipulate atoms using a scanning tunneling microscope in 1989. He used 35 cyanide atoms to spell out the IBM logo. He shared the 2010 Kavli Prize in Nanoscience for this work.
Its initial commercial application. The early 2000s to the beginning of the use of nanotechnology in commercial products, although most applications are limited to the bulk use of passive nanomaterials. Examples include titanium dioxide and zinc oxide nanoparticles in sunscreen, cosmetics, and some food products, silver nanoparticles in food packaging, clothing, disinfectants, and household appliances, such as silver nano, carbon nanotube for stain-resistant textiles, and cerium oxide as a fuel catalyst. As of March 10, 2011, the Project of Emerging Nanotechnologies estimated that over 1,300 manufacturer identified nanotech products are publicly available. with two new ones hitting the market at a pace of 3 to 4 weeks. Potential uses: the Joint Center for Biotech in Canada ranked potential uses of nanosciences and nanotechnologies with respect to development. The top 10 uses follow the BBC News 2005.
Thank you for watching. Group 16. Herges, Chris M. Delmont, Marliza Borgonia, Mary Chris M.